students. Now today's session will start matrices competitive class. Already relation functions competitive is over. The next chapters matrices and determinants competitive will start. Before that we will discuss some synopsis related to matrices. Later we will discuss for determinant chapter. First, matrices. What is meant by matrix? A rectangle array of contains objects or elements having m rows and n columns. M rows and n columns means it is a rectangular array. It is denoted like this. And one more thing, matrices denoted by only capital letters. Capital A equal to Aij, having m rows and n columns. Then order of this matrix. How to write? What is the meaning of order? Order of the matrix means the number of rows cross number of columns. Otherwise you can read rows by columns. M cross n. Here m by n is the number of rows cross number of columns. That is called order. Order of the matrix means number of rows cross number of columns. And one more thing, matrices denoted by only capital letters. Now we learn what is the order of the matrix. Now next, we learn some types of matrices. In this first one, row matrix. Row matrix means a matrix having only one row. So any number of columns is not a matter. But a matrix having only one row, that matrix is called a row matrix. For example, you can take like this. Here I say one row, any number of columns. For example, take 1, 2, 3, 4. What is the order of this matrix? Row means horizontal, column means vertical. Already we discussed in PU. Number of rows here clearly one row cross. Columns only are there 1, 2, 3, 4. Clearly it's a row matrix. There is only one row is there. Next, column matrix. A matrix having only one column and any number of rows, no column. So here you can write, here is a, for example, m by 1. Here m rows are there but having only one column. It's clearly which matrix? Column matrix. For example, 3, 4, 5, 6. Here how many rows are there? 1, 2, 3, 4. Column is only one column. That's why it's clear which matrix? Column matrix. Coming to a rectangular matrix. Rectangular matrix means a matrix in which the number of rows is not equal to number of columns. The number of rows is not equal to number of columns. That matrix, that all matrices are called which matrix? Rectangular matrix. Here rectangular matrix means you can take any examples. 2, 3, 4, 5, 6, 7. Here how many rows are there? What is the order of this matrix? 2 rows, 3 columns. So it's clearly which matrix? Rectangular matrix. Next, square matrix. Square matrix means a matrix in which the number of rows means m is equal to number of columns. Rows and columns both are equal. That matrix is called which one? Square matrix. Square matrix means, for example, 2, 3, 4, 5. What is the order of this matrix? Having 2 rows and 2 columns. That is a simple meaning of which one? Square matrix. Coming to next important definitions. What is meant by diagonal matrix? Before that we learn one more thing. Principal diagonal. What is meant by principal diagonal is, in a square matrix, the elements lying along the diagonal. In what is the diagonal? How to identify means the row position and column position both are same, such elements is lying along the diagonal, that elements only we called as principal diagonal. For example, I will take a 3 by 3 matrix with general form. For example, A11, A12, A13, A21, A22, A23, A31, A32, A33. In this, the elements lying along the diagonal of the square matrix, these all elements clearly having row and column position both are same. First row first column, second row second column, third row third column. These elements we called as a principal diagonal elements. So what are the elements here there? Principal diagonal elements are A11, A22, A33. This principal diagonal is possible only for square matrices, not for rectangular matrix. Let's come to the next one. Diagonal matrix. The meaning of diagonal matrix: a square matrix in which all non-diagonal elements are zero. Non-diagonal elements means, for example, 1, 0, 0, 2, 0, 0, 0, 0. This clearly I said it's a diagonal elements. Remaining all are called non-diagonal elements. A square matrix in which all non-diagonal elements are 0, that matrix is called a diagonal matrix. Next, scalar matrix. Scalar matrix means a square matrix in which all non-diagonal elements are 0 and diagonal elements are same or equal. For example, I am taking 2, 2, 2, 0, 0, 0. Non-diagonal elements are 0 and diagonal elements are same. That matrix is called a scalar matrix. Next, unit matrix. Another name is identity matrix. Same a square matrix in which all diagonal elements are equal to 1 and non-diagonal elements are 0 is called a identity matrix, denoted by this order is what clearly 3 by 3. Generally denoted by capital I is identity matrix. Now is a third order means we can denote like this I3 also. I3 means what here? Third order matrix. Diagonal elements are equal to 1 and non-diagonal elements are equal to 0 in a square matrix. That one is called an identity matrix. You can take 2 by 2. For example, second order matrix you want means you take like this 1, 0, 0, 1. It is a second order identity matrix. Next, 0 matrix or null matrix. 0 matrix or null matrix. What do you mean by 0 matrix or null matrix? A matrix in which all elements are 0, that is called a 0 matrix. In this, rectangle matrices will be there or square matrices will be there. Example, 0, 0, 0, 0. It is also 0 matrix. Denoted by 0 only, big 0. Okay? This is also 0 matrix only. In this, not restricted for only square matrices. You can take a rectangle matrix also. Next, upper triangular matrix. Upper triangular matrix. A square matrix in which the elements below the principal diagonal 0 is called the upper triangular matrix. Read again once. A square matrix in which elements below the principal diagonal are 0. Which are elements lying below the principal diagonal? That elements are 0. That matrix is called a upper triangular matrix. Clearly, this is principal diagonal 1, 4, 5, 1, 4, 6. Below the principal elements are 0. That is called an upper triangular matrix. Similarly, lower triangular matrix. Lower triangular matrix. Same definition, but in small changes here. In the place of below, we have to put above. A square matrix in which the elements above the principal diagonal are 0 is called a lower triangular matrix. Example. See, this is the elements above the principal diagonal, and this 1, 3, 7 is the principal diagonal. In a square matrix, above the principal diagonal elements are 0. That is called a lower triangular matrix. Okay, next topic. Trace of a matrix. Written by trace of a matrix. In a square matrix, sum of all principal diagonal elements. Sum of principal diagonal elements is called the trace of a matrix, denoted by, for example, how to denote this? Denoted by, for example, A is a matrix means trace of a matrix denoted by PR of A. Or capital T, no problem. Trace of a matrix means the sum of principal diagonal elements in a square matrix. For example, I am taking A matrix like this: 1, 2, 3, 5, 6, 7, 8, 9, 10. Which is called principal diagonal here clearly? This is the principal diagonal. Trace of A matrix. Trace of A equal to, how to find this? Sum of principal diagonals 1 plus 6 plus 10. Still how much? 7. Just we need to add principal diagonal elements in a square matrix. That is called a trace of a matrix. Having some properties related to this. First one, trace of some lambda is a scalar into A matrix. How to find this? Lambda is a constant scalar common. Trace of A, lambda is scalar. Scalar means non-zero real number. Next, trace of A plus B equal to, how to find trace of A plus trace of B. Next, third one, trace of AB equal to, we can find trace of BA. For this both trace values, trace means sum of diagonal elements, both will be equal. Next, transpose of a matrix or transpose matrix. What do you mean by transpose of a matrix? A matrix in which by interchanging rows and columns. is also there in PU. A matrix in which interchanging rows and columns is called a transpose of a matrix. For example, a matrix A is given like this, general form A is M by N. Transpose of a matrix denoted by A dash or A power T or A power transpose. You want to find A dash or A transpose. How to find this? Interchanging row position and column position. So here I is called row position, J is called column position. These both positions will be changes. Now what will you get here? A, J, I. Rows and columns are interchanging. So N by M. For example, a matrix A is given 1, 2, 3, 4, 5, 6. What is the order of this matrix? 3 rows and 2 columns. You want to find out transpose of this matrix, A dash. Changing rows into columns. This is first row, right into first column. Second row changing into second column. Third row changing to third column. Now what is the order? Clearly 2 rows, 3 columns. Now in this, actually A matrix is 3 by 2. Now after transposing, this becomes 2 by 3. Now having some properties here also related to transpose of a matrix. First one, A transpose whole transpose equal to A. Second one, A plus B whole transpose equal to A transpose plus B transpose. Next, third one, AB whole transpose equal to B transpose into A transpose. These are simple properties related to transpose of a matrix. Next, symmetric matrix. Symmetric matrix means a square matrix is said to be symmetric if A transpose equal to A. Transpose of a matrix and A matrix both are equal. That matrix is called a symmetric matrix. Example, matrix A I am taking 1, 2, 2, 4. Simple, 2 by 2 matrix are there. Apply transpose of this matrix. What do you get? Same 1, 2, 2, 4 only. This clearly equal to which one? A matrix. That's why symmetric matrix means simple definition. Transpose of matrix equal to same matrix we got, that is called a symmetric matrix. Next, skew-symmetric matrix. Same, a square matrix is said to be skew-symmetric if A transpose is equal to minus A. Here one more thing you should remember. For every skew-symmetric matrix, diagonal elements are always 0. Then only this condition is applicable for any square matrix is said to be a skew-symmetric matrix. For example, a matrix here I have taken like this: 1, 0, 2, 3, minus 2, minus 3, 0, 5, minus 5, 0. Clearly, you need to identify first skew-symmetric matrix when it is possible. In the square matrix, diagonal elements compulsory 0. Any one element is non-zero also, that is not a skew-symmetric matrix. For example, apply transpose for this. And one more thing, for non-diagonal elements, signs are opposite. Diagonal elements are 0, compulsory. For non-diagonal element, sign opposite will be there. Here 2, here what is there? Minus 2. Here 3, minus 3. 5, minus 3. Transpose apply, what will you get? 0, 2, 3. Changing rows and columns. Minus 2, 0, 5. Minus 3, minus 5, 0. and take minus common from this. If you take minus common, what will you get? 0, 2, 3, minus 2, 0, 5, minus 3, minus 5, 0. It is clearly which one? A matrix. Total, what you got here? A transpose equal to minus A. So clearly it is which matrix? Skew-symmetric matrix. And for skew-symmetric matrix, there is some properties related to this for both. For symmetric matrix and the skew-symmetric matrix. In this first one, if A is symmetric, then minus A, K into A power n. This all matrices are also symmetric matrices only. N is a integer. Next, second one. If A is skew symmetric, K is a constant, non-zero constant I can take. If A is a skew symmetric, then clearly A power 2n, n is the integer, 2n will become even number. A power 2n is symmetric, not skew symmetric. And similarly, A power 2n plus 1. 2n plus 1 becomes odd number. When A is a skew symmetric, A power 2n is symmetric, and A power 2n plus 2 is skew symmetric. Skew symmetric matrix. Next, for every square matrix, A always A plus A transpose is symmetric. For every square matrix is symmetric, and A minus A transpose is skew symmetric. Next, fourth one. If a square matrix A is both symmetric and skew symmetric, then that matrix compulsory is a zero matrix. A square matrix A is both symmetric and skew symmetric. And skew symmetric, then A is a zero matrix. How it is a zero matrix? Simple logic. If A is a symmetric, what is the condition? A transpose equal to A. A is a skew symmetric, what? A transpose equal to minus A. As per definitions. Now from this we can prove that A is a zero matrix. How? Left side both are same only. We can compare right side terms. What? A equal to minus A. Minus A take this side. 2A equal to 0. Then A is equal to what? Zero matrix. Next. All clear? Understood now? So, how it is a zero matrix. Next, coming to fifth one. If A and B are symmetric, then the combination here AB plus BA is always symmetric. When it is possible, A and B are symmetric, then AB plus BA is symmetric, and AB minus BA is skew symmetric. Next, matrix polynomial. Already we know a polynomial equation. If a matrix satisfies, actually it is square matrix, not better. Square matrix satisfy a polynomial. Polynomial equation is f of x equal to a general form of polynomial a0, a1x, a2x square plus and so on, an x power n. When the square matrix A is satisfied the polynomial, in the place of x we need to substitute a. Then it will becomes f of a equal to, this complete equation converted into matrix form. That's why here no x value. That's why we need to replace with I, identity matrix. A naught I, a1 in the place of x take a2 a square plus and so on an a power n. This is called a matrix polynomial. From general polynomial equation to convert in the form of matrix form. Next, conjugate matrix, conjugate of a matrix. Conjugate of a matrix means that clearly when the conjugate of matrix is applicable, the matrix contains complex numbers. Now in this case, a matrix in which replacing every complex number with its conjugate, that matrix is called a conjugate of a matrix. For example, A is a matrix means conjugate of matrix divided by A bar. Right? A square matrix in which replace each element with its conjugate complex number. Conjugate complex number is called conjugate of a matrix. Denoted by what symbol here? A bar. For example, I am taking the A matrix like this. Simple. 1 plus I, 2 plus 3i, 3 plus 4i, 1 minus I. You want to find out conjugate of this matrix. How to find A bar? Each element replace with its conjugate of the complex number. 1 plus I, what is the conjugate? 1 minus I, 2 minus 3i, 3 minus 4i, and 1 plus I. The simple example for conjugate of a matrix. And what are the properties related to this? First one, A bar whole bar equal to A. Conjugate of conjugate is we get original one. Second one, alpha into A whole bar. In this, alpha bar into A bar. Why I am taking for alpha is a scalar, generally any number. Alpha is any number. Any number means it can be complex number also. When complex number we need to apply conjugate for that number also. That's why alpha bar into A bar. Next, third one. A plus B whole bar equal to A bar plus B bar. Next, fourth one. AB whole bar equal to, directly we can write A bar into B bar. These are the properties for conjugate of a matrix. Next, transpose of conjugate matrix. Transpose of conjugate matrix means, already conjugate matrix means we know A bar. The transpose of conjugate matrix is called transposed conjugate matrix. How to denote this one? A bar whole dash or A dash whole bar. This both combination divided by likely, that is A power theta. This is called a transposed conjugate matrix. How to find this one? Applying transpose for conjugate matrix is called a transposed conjugate matrix, or simply called as transpose of a conjugate matrix. The combination of these two denoted by which one here? A power theta. Now from this, for example, in matrix A, I am taking like this: 1 minus I, minus 2 plus I, 3 minus I, 4 plus I. This is a matrix A. First we need A bar, no? Find the A bar. What is A bar? We will get 1 plus I, minus 2 minus I, 3 plus I, 4 minus I. This is A bar. How to get this A power theta? That is transposed matrix. A power theta means simple. For A bar, we need to apply transpose. Apply transpose for this matrix. What do you get? 1 plus I, minus 2 minus I, 3 plus I, 4 minus I. This is called a simple meaning of transpose of conjugate matrix, having some properties related to this. What are the properties we need to follow for this also? First one, A power theta whole power theta is equal to A. How you using properties in that? In general form of transpose, like that here also. Second one, Ka whole power theta. Here, one more thing you should remember, you are applying conjugate concept also here. So here for K, we need to take bar. It is a number. So sometimes K is a complex number, we need to take conjugate for that. Into A power theta, K is any number. Any number. Next, third one, A plus B whole power theta. In this, A power theta plus B power theta. Next, fourth one, AB whole power theta. I will apply AB whole dash, B dash into A dash, like that. Here also, B power theta into A power theta. These are the properties related to transpose of conjugate matrix. Next one, unitary matrix. A square matrix is said to be unitary. Is said to be unitary if A power theta into A or A into A power theta is equal to identity matrix. Then already A power theta I said, A power theta means transpose of conjugate matrix, A bar whole dash. That is called A power theta. Now A power theta into A or A into A power theta gives identity matrix. That matrix is called an unitary matrix. Next, Hermitian matrix. This is all related to complex number matrices only. Conjugate matrix, transpose of that matrix. Hermitian matrix, A square matrix. Said to be Hermitian if A power theta equal to A. A power theta means what? That is A ji bar. Transpose ಮಾಡಬೇಕು conjugate ತಗೊಳ್ಬೇಕು. That's A ji bar ante equal to A ij. The small A ij is an element of A matrix only. Okay. Now example. a matrix A like this. I am taking the elements AB. You will take some C plus ID, here C minus ID. Here, when Hermitian matrix is possible, compulsory these two are real numbers. Here, if you take complex numbers, it is not possible for Hermitian. Remaining non-diagonal elements are you can take complex numbers possible. Now check for this. A bar theta means what? A bar whole dash. A bar means what? Transpose conjugate will take for every complex number. These two are not complex numbers. That's why same numbers will be AB. C minus ID. C plus ID. For this we will take whole dash transpose. For this matrix transpose apply, what will you get? A C minus ID C plus ID B. This matrix completely which one? It is a A matrix. So from this what you write? A power theta equal to A. Now this is a clearly Hermitian matrix. Next, skew-hermitian matrix. Skew-hermitian matrix, say a square matrix said to be skew-hermitian if A power theta equal to minus A. Here, that is Aj bar equal to minus Aij. These are elements. Element symbols. These are also notations. For example, here also, when this skew-hermitian is possible, diagonal elements compulsory having 0 elements and non-diagonal elements having opposite sign will get. For complex numbers also same. Diagonal elements are 0. I am taking 2 by 2 only for easy purpose. 1 minus I. Here I will take minus 1 plus I. All of understood? If we take minus common from this, we get same notation. 1 minus I minus 1 plus I. We are proving A power theta equal to minus A. We will check the condition. How to find this one? A bar whole dash. A bar. Apply bar for that. What will you get? 0, 1 plus I, minus 1 minus I, 0. Whole dash. I will take minus common from this matrix. So transpose apply first. Before taking common, apply transpose. What will you get? 0, 1 plus I, minus 1 minus I, 0. Now I will take minus common from this. If you take minus common, what will you get? Okay, small correction here. A matrix take 0, 1 minus I. Here take minus 1 minus I. Because we need to take A bar whole dash, we need to get minus A bar, A matrix. Now first A bar apply, means conjugate 0, 1 plus I, minus 1 plus I, 0, whole dash. Now apply transpose for this, what will you get? 0, 1 plus I, minus 1 plus I, 0. Now I will take minus common from this matrix. A power theta equal to, if you take minus common, minus 0 is 0 only. If you take minus common means minus 1 becomes plus 1, plus I becomes minus I. Here, both are positive. By taking minus common, both will becomes negative and 0. It is clearly which matrix? A matrix. Now from this what you write? A power theta equal to minus A. This is clearly skew-hermitian matrix. So next one, few more definitions we should learn. These orthogonal matrix. A square matrix said to be square matrix A, and then A matrix is said to be orthogonal if A into A dash or A dash into A equal to identity matrix. When this condition is satisfied, that A matrix is called an orthogonal matrix. Next, idempotent matrix. Idempotent matrix. A square matrix said to be idempotent if the condition is A square equal to A. The square of matrix you got again the A matrix only, then that matrix is called an idempotent matrix. Next, involuntary matrix. Involuntary matrix. Conditions, remember, for orthogonal matrix condition is A into A transpose or A transpose into A equal to I. For idempotent matrix condition is A square equal to A. Sometimes they will give just name of that matrix. If you remember condition only, you can solve the problem in commutative ways. Next, involuntary matrix. A square matrix said to be involuntary if A square equal to I. When this is a condition for which matrix? Involuntary matrix. Next, nilpotent matrix. If A is any square matrix and M is a positive integer, then this condition satisfied A power M equal to null matrix. Here M is positive integer. A square matrix or for any square matrix. Any square matrix A such that the condition is such that if A power M equal to null matrix, then this A is called an nilpotent matrix. Here M is any positive integer. This is the condition for which matrix? Nilpotent matrix.